Amazing, thank you very much. All right, so let's start. So this is the Flux Office Hours. I'm Paulo Gomes, Senior Software Engineer at Weaveworks. I'm also a maintainer in the Flux team. I'll be joined later by Kingdon, who you guys just heard the voice of, who is DX Open Source Support Engineer at Weaveworks as well. He'll be also replying to some of the messages in the chat. So anything you guys can just shout. All right, let's crack on. So what we have in store today is pretty much I want to talk about some of the improvements and features we recently released, and also cover like quite a few of the things I'm really excited about that are underway, that we're working and we might release in the next release or two. After that, we will switch gears and talk a bit about debugging Flux controllers. We're not going to go into much depth in all the possible ways of debugging Go, but we will definitely kind of get people up and running quite quickly, especially when we'll be talking about Flux controllers. And at the end, I'll be joined by Kingdon on a Q&A session. Brilliant. So first of all, I wanted just to make this crystal clear that a lot of the features that I'll be talking about, they're actually a combination of loads of people, right? It's not something I can take credit myself, but actually this is the collaborative work of Flux engineering, the Flux engineering team, other maintainers, and also the overall Flux contributors. So yeah, just bear that in mind as I go talking to about the features, and especially as I get overexcited about them. Don't think that I've done all the work by myself, because I definitely didn't. Cool. So let's start. So one of the key things I definitely want you to make sure that everyone is aware. We talked about this quite a bit. We released a few fixes for some security issues recently, and they encompassed pretty much 3 CVEs. All of this was found and mitigated by the Flux team before it was found in the wild, which is always a positive thing. Things that I want you to make sure that people are aware. First, if you bootstrapped your cluster using Flux CLI version 0.29 or beyond, you're already patched up, so you don't need to worry about neither of those CVEs. If you're not, I would definitely advise you to patch as soon as you can. Most of those CVEs that are more concerning if you have a multi-tenancy deployment. So yeah, if you have a multi-tenancy, I would say don't wait, just go and patch them ASAP. There is more information about them on the advisory, so the link is just there. But on top of that, I wanted to kind of highlight 2 breaking changes that I encompassed on these fixes. So the first one is around the second CVE, which is customization files allows for path traversal, which is in very specific scenarios, a customization file could link to something on the pod file system, which then would be used during the conciliation. This is now blocked, which means you can only use things that are within your customization project file, which is the way to be anyway. If users were relying on that before, I advise to make sure that those files are actually on their sources and not on the file disk of the pod, of the source controller pod, or actually in this case customized controller pod. Okay. The second breaking change on this is about the last security issue. So the last one is it affects remote reconciliations, right? So Flux can operate in 2 ways. One, and is probably the most used one, is in cluster reconciliation, which means Flux will reconcile its own cluster. That's it. you can deploy things into different namespaces, but that is the limit of it. The second part is when you use a cluster or a Flux installed in a cluster to manage other clusters, which we call remote apply or remote reconciliation. To use that feature, you need to provide a kubeconfig to either your Helm release or to your customization object. And that kubeconfig in general would have, the target cluster would have the certificates, maybe a token, a username and password. Again, it depends on how your cluster is configured. But one thing that some folks are not aware is that kubeconfigs allow that you define a command to be executed on demand, which will then yield a token to be used for that authentication. An example of this in practice is what EKS uses, which is the IAM AWS Authenticator, I think, which is a SIG project as well. So what that will do is pretty much every time you're trying to do a kubectl command, it will, run that command first, get a token, cache the token, and then keep using that token for all the commands until that token expires. On this case specifically, a malicious user could use this to privilege escalate. And again, this is more problematic on multi-tenancy. So the breaking change regarding this is execution of commands on kubeconfigs are disabled by default now. Right? You can still enable it with a new flag we introduced in both Kustomize and Helm controllers. But if you are to use it, I would recommend to kind of enforce what binaries you're executing and so on, based on probably AppArmor or SE Linux profiles, just to make sure that they can only execute what you want them to execute. So yeah, that's it. So again, if you guys need any more questions, if you guys have any other doubts about the security fixes, again, refer to the advisories or ask us later on the Q&A. Cool. Another one is the Helm caching in source controller. And then most probably some folks would be thinking like, why? Why do we need to cache Helm repository indexes in source controller? The reason for that is how well Helm repositories are handled, right? So they are YAML files. They can be quite big ones. For example, the biggest one I know is the Bitnami. It's about 15 megabytes. And the way we process YAML files is based on the Kubernetes SIG YAML library, which is used throughout Kubernetes, right? So this is the same behavior throughout. And what it does is it wraps a YAML library, which is GoYAML, which parses the YAML file into JSON, and then it runs JSON on Marshall. So we kind of doing two kind of deserializations in a way, like we're converting from YAML to JSON and then from JSON to Go object, which is not great. But the reason why this is done is when you're parsing YAML and you have specific types that needs to be handled in a particular manner, you can define, well, in JSON, you can define a Marshall JSON function, which will be called automatically through that Marshall process. YAML doesn't have that, which means if you just do a Marshall directly using the GoYAML library, you might have different results, like of what the Go object you get, which is not great, right? Just to understand the impact of this, I've done some benchmarkings between the Kubernetes YAML Marshall process, which is what we use, and Kubernetes as well, and the basic GoYAML versions 2 and 3. And if you notice, the first line, it takes a lot longer in terms of time, but in terms of memory, just to parse the bitnami repository index file, it costs about 400 megabytes in memory footprint. This is not, necessarily in one go. Like, you might not see that spike on your metrics, for example. But if the resource limits are really kind of low, these will force your source controller to be killed because it ran out of memory. Because again, like, C groups will enforce those limits quite more sharply than the samples you gather from the metrics. So again, like, this is one of the problems we have, and it's not really our problem, it's more upstream. So what we're doing with the Helm caching is pretty much making sure that is processed once, and then we just reuse that object in memory, which then is a lot lighter and so on. This is a opt-in feature, which means it's not going to be enabled by default. It does not make the process of parsing Helm repository indexes more efficient, but what it does is it processes it once, caches it, and then it will lower your average memory footprint. This is especially important if you have loads of different Helm repositories being processed, and if they are potentially being run in parallel, they might require your memory limits to be a lot higher. Because again, if one repository might cost up to 400 megabytes in memory footprint, if you have like 5-10 of them running parallel, you might have quite a substantial memory footprint impact. We're looking into some optimizations on this later on. I'll briefly talk about that, but I just wanted to highlight that this is is not what we're doing right now. We just have the caching, which will already help a lot the users, and this is already shipped. Cool. Another one, which is actually quite exciting, is disable of remote bases and customized overlays. So folks, most of the times, are not really excited about being able to disable features, but given my security background, I do get a bit excited about those things. So what does this mean, right? So imagine you have your Kustomize for a given cluster. You have all your overlays defined, and you might get a whole base from a remote target, right? So, and you do that because pretty much you want the latest, right? You want to get it straight from the source, and that's it. There are a few issues with that I personally think is not a great idea to do that. First is you kind of lose the whole idea of hermetic deployments, which means your estate is no longer, the source of truth of your estate is no longer your repository or your bucket, but now is a combination of that plus all these remote estate that you pull on demand, which means if you deploy the same thing twice, depending on external factors, you might have completely different results. Another problem with using a remote basis is that if that remote is compromised, you have absolutely no idea what's being deployed. You have what I would recommend instead of using this is you actually have a different process that tracks the changes of whatever you want, this remote base, and then it creates a pull request against your repository, which then you can see what the changes are and have all the security controls in like peer reviews and so on enforced to make sure that only goes into your environments what you actually know. So this new flag on Kustomize controller is false by default, which means it's backwards compatible. It's not going to break folks that were using that before, but I personally think that folks should move away from that behavior as it's not great from a security perspective anyway. Cool, brilliant. Let's switch gears and start talking about the improvements that are underway and I'm really excited about. Some of them are kind of happening for a while, and yeah, I'm really excited that they are really close to arrive. So the first one is about OCI support for Helm charts. We have the RFC already merged, and now we have the implementation, which is almost merged. It's approved by a few maintainers already. There was a lot of feedback on it, and now I think in the coming days, maybe next week, we have it merged. What this will do is it will allow users to fetch their Helm charts directly from an OCI server, or at least kind of use the OCI as like a repository index as such as well. And the meaning and how that, well, that improves a few things, right? First, what we just talked about, the whole idea of how YAML is expensive to be processed. So that will no longer exist on that specific scenario. Like you just go directly to OCI, making the use of Helm charts within Flux a lot more streamlined and resource and less resource intensive as well. So yeah, that is really, really good. This has been one of the most asked Flux Virtual features for a while, and I just wanted to kind of give a great shout out to Sole and Makis who worked a lot on this. I wanted to briefly talk about the same thing but for manifests, just to make sure we don't kind of have a confusion of what is coming really soon and what might not come as soon. So the support for Helm should probably come on the next minor release. The support for manifests, so for example, you can have your YAML manifest on an OCI server. This support is not there yet. We still are at RFC stage, so the discussion is still going on this pull request that excuse me, I'm sharing there. So if you're interested on this specific subject, please join in the discussion. But I would assume these won't be around for at least another 2 or 3 minor releases. Yeah. Cool. Git Clone Optimisations. Yeah, this one is definitely really close to heart. And basically, I just want to emphasize what does this entail. So currently, we have 2 Git implementations, right? So one is GoGit, another one is libgit2. GoGit supports shallow clones, libgit2 doesn't, which means every reconciliation, GoGit would do a shallow clone and libgit2 would do a full clone. But still, if from the previous reconciliation to the current one, there were no changes to your repository, you will still do a clone regardless in both cases. So you have that constant bandwidth cost in terms of network. There would be CPU and memory costs as well, but maybe not as much as the network, but that would be constant. So if you have your as you decrease the intervals of your reconciliation, the cost in terms of resources will be exponential, right? Because they'll just keep growing, but actually it's linear in this case, actually, sorry. But they'll continuously just grow, just increase more and more. What we're doing now is really actually subtle optimization, which is the reconciliation starts with a remote LS, which means for HTTPS or HTTP clones, you will actually go to the server, get a HTTP request for one specific resource, which is the mapping of all the references on the server and the latest hash commits or commit hashes. And then what we do is we check, is this exactly the same as the previous one? If it is, that means there's no change, we don't need to do anything, and then we short circuit the whole process. We don't clone, we don't download the repository, we just move on and mark that reconciliation as successful. Obviously, there are some housekeeping that we do behind the scenes, but from a resource perspective, it's a lot lighter, which means the clone operations will be short-circuited whenever possible. There are some optimizations we're doing around things like, if you change your git ignore, for example, we want to carry on with the reconciliation, so we will make sure that that happens, although the revision hasn't changed. But again, like all those kind of things are fine-tuning things that we're adding into this process to make sure that it will be optimized, but it still work as you expect it to work. Another thing that is great is it massively decreased the gap in resource utilization amongst the two implementations, right? Because it means that it will only cost once on the clone, but then every time that we're checking if there is a change, which will be most of reconciliations, you have no cost at all, or a very low cost, which is most of the time just a HTTP request. And I think the most useful part of this is that lowering the intervals has no cost, which means you can lower your intervals to make sure that as soon as there is a change, you know that and act accordingly, but you don't have that resource cost every time just to do that. One thing to think about around this feature is we implemented, as part of this, we implemented a feature gate mechanism to allow folks to opt in and out, in the future as we kind of bring new things like that. And this feature will be enabled by default, hopefully on the next minor, which is probably happening next week. So yeah, really excited to see what folks think and how they use it. Another thing that we've been working on for a while now is libgit to manage transport. Just to kind of have some context, so this is shipped already for a while, but it's an opt-in feature. The libgit2 is actually a C library, which is then wrapped around Git2Go, which is what we use, right? And given how it's all wrapped around, we have very little control about, enforcing timeouts, if the state gets corrupted or anything like that. It's quite hard for us to kind of recover. And this managed transport, what it does, it kind of resolves all those problems, bringing the transport for Git connections completely into Go, which is exactly what we have for the Go Git implementation. This would improve resilience and reliability, and I'm actually quite expensive. I'm quite excited to see this happening, so we don't need any more libssh2 and OpenSSL, both for development and later on in when we ship it, when we build the controller. Cool. Before I forget, this will be enabled by default on the next minor release, most probably. So yeah, again, really excited to see this being shipped. There is a lot happening around unified standards across the controllers. There was a massive work by Hide and Sonny on Source Controller for version 0.22 of Source Controller, and before that as well. And now they're rolling out a lot of those great practices across all the controllers. One of the things that I'm really excited about is on Helm controller. It is improving a lot the observation model for the Helm charts. So a lot of the issues that users have sometimes, for example, the exhausted retries, all that would go away. And again, it will improve not only the resilience of the whole controller, but also the performance of it. If you're interested a bit more about, what we're planning for those things that we're rolling out across the controllers, I linked a few of the issues and also the documentation of the source controller, which kind of gives a bit more information about that. Cool. I think getting short on time. So let's crack on debugging Flux controllers. Key thing here is why I'm talking about debugging Flux controllers, right? And it's first, this makes it a lot easier for folks that maybe haven't ever worked with controllers before and they want you to debug and step through the code without, like fear of, like, how do I understand this? What happens when, and so on. Like, by stepping through the code, it tends to be a lot easier, which kind of lowers the bar for anyone to contribute. So maybe you contribute on a PR, but some tests are failing and you can't really debug it, especially if you're using source controller. And then, like, what do? You need to kind of lean on other people. So the idea is to kind of help people to be self-sufficient on that perspective. And the reason why I mentioned source controller is that it is probably the hardest one to debug. The reason being, we depend, as I said before, on libgit2, which then depends on OpenSSL and libssh2. If we don't have all those properly configured, it will just not work. So yeah, I'll go through that. Things that we'll need, we'll go through this on VS Code, and you need the Go extension installed for a better experience. And on top of that, you need Delve installed. I'll quickly show how Delve can be installed once you have the Go extension. But yeah, that's pretty much what you need, and the source code for the source controller as well. So let me share my other screen, just a second. All right, so let me share my screen. I'm on VS Code and I want to install Delve to be able to kind of debug. So one of the things you can do is just, if you do, I think it's Control-T, and then you can go to Go, install and update tools. You have all the tools related to Go here. You can just kind of select Delve and it will automatically install that for you, the latest version, and make sure that is on your Go bin directory. Cool. All right, now I want to debug this test, right? Let's say that this test is not working. Just to kind of give a bit of context on this test, when we start implemented managed transport, we noticed that the redirect between HTTP and HTTPS wasn't working. So we created this test to make sure that it would always have something to make sure we don't break that behavior. If I run it, it doesn't work because all those flags that I mentioned are not set. Because of, again, like, unless you configure things at a machine level, which I don't think users, and developers shouldn't do anyway, because you might have a different version of the libgit2 or other dependencies. What we did instead is we isolate all those dependencies. As you do, like any make targets, they will come here into your build libgit2, and then you have the different versions as we kind of progress and all. Now what we need to do is make sure that all those settings that we have defined here, the package config path, the CGO LD flags, like all those things, we need to pass that on to VS Code or to any other IDE you're using. We created a target that pretty much creates a environment file for that, which is this guy here. So if I go there and do a make env, it will create the file for us. So if I go, where is that again? So build env file, and there we go, all the files here. So, but this doesn't help at all unless I tell VS Code how to get that file at the time that it's trying to debug, right? So you can do that through settings, and you have a setting test environment file. I just, just to make it easier, I'm copying the actual value, saving this, and then if I go and run, it will pretty much just work, right? So it takes a bit of time because of setup and all, but yeah, worked. And the same thing for debugging now. If I click debug test, I can pretty much step through, can go like step into, go like all the steps and see what's happening in the code. So this is all well and good. When we're talking about tests that are already in place, there's a lot of tests across the application. But imagine that you actually experiencing a behavior that you haven't seen before and you don't understand why that's happening. So what you can do is step through the application, right? So if we were to do that, so let's pretty much do a start debugging, right? If you do a start debugging, you get the exact same problem. The reason being, they happen in a completely different manner, right? So when you're running your tests and when you're trying to debug the full application, the whole thing is kind of set up in a different manner. So what you need to do here is create this launch.json file. So if we go to that now, there's pretty much nothing. I have one that I set up before here. I'll just kind of copy that across and kind of walk through that and explain what each part does. But basically what we do here, the key things are, I set that environment file, because again, I can have that environment file and use that across all the things. And every time that it changes, everything gets automatically updated. Another thing is, what is the entry point of this program? So I just set the main of the controller to make life easier. As I'm really into the experimental Git managed transport, I'm keeping that enabled for the time being, but that will be enabled by default, as I mentioned before. And a few other things that are important for me. So for example, when I'm debugging, I don't want concurrency. I don't want like parallelism of any shape or form unless I'm testing something specific to that. Otherwise, it would just add a lot of information that, or kind of noise that I don't really need. Sometimes I might want to change the log level. So all these settings here are the arguments to the executable of the controller. So I'm pretty much saying, I just want one worker to happen at any point in time, and I want the log level to be, in this case, trace. Another thing to think about is I have a kind cluster here that literally has nothing. The only thing that I've done before starting this was a make dev deploy to deploy the CRDs and so on, but then I removed the deployment. So I could do that manually, but again, I'd rather do that this way. Given that my Kubernetes cluster, my kind cluster is already on the context, if I just go now, save this file first, and I do a start debugging, it should just work, right? One thing that I created, let me just see that is there. Yeah, so I have a Helm repository, and as the Helm repository is getting reconciled, I get to step through the code in the same way. I can go there step by step, see what's the settings, check everything, see the checksum of that index. This is the expensive operation that I mentioned before. So here I have the checksum and so on. So again, this pretty much allows you to go through the entire process quite easily, really. Some of this documentation, some of this is already documented on our development MD. So if you go at the bottom of it, we talk about the key things here, which is the environment file, how to create it, which is there we go, make env, and that's it pretty much. But things that we want to involve in the future is kind of give a few more tips about changing the argument files, make sure that you're not running concurrent with high concurrency and so on. But yes, that is pretty much that from the demo. So we can go back to my other screen. And now that is really, that's it really. So now pretty much we can go for Q&A. So if you guys have any questions about anything that we talked today, the demo, or anything that is not part of what we discussed, Kingdon and I would be more than happy to try to answer the questions.
That was a great demo.
Thank you. Yeah, I suffered a lot with source controller. So I was like, well, we need to make sure that folks know how to kind of play around with this, especially around the libgit2 dependencies. So yeah, that should be easy.
Yeah, I've heard of Delve before, but I had never attempted to debug the source controller or any of our other controllers. So I'm sure I wouldn't have been able to figure it out on my own.
Well, to be honest, it is quite challenging with those dependencies and not knowing where they're based and all that kind of stuff. So yeah, hopefully soon we don't have as many dependencies around, so it would be kind of easier for folks to debug if they so wish. But yeah, it's one of those. Did we get any questions so far?
I opened up the Q&A panel a little while ago. I'm not sure if people saw it. I didn't realize that we had to actually open it. So it's been open for about 10 minutes, but we haven't got any questions yet.
All right. Well, it would be good as well. Maybe if people don't have questions, if they have at least like things that they would want the Flux team to kind of talk about, things that maybe they don't have as much information. Yeah, like anything, we're here to pretty much try to help as much as possible. Although my internet is now saying that it's slightly unstable. Well,
you're coming through fine.
So what's your favorite feature in that happened in the last while, Kingdon?
I'm a big fan of that no remote basis feature. I'll tell you why, because I've been doing demos and trying to help build up my knowledge and my sort of portfolio of how to use Flux. And this is one thing that I did not really understand in detail what I was doing or what the potential harm of that was. The biggest thing that I don't think I heard you mention is performance. As far as those remote bases, if you'd like to reconcile your customization more frequently, that means you're going out and fetching a Git repository with the Kustomize controller frequently, potentially. That's very resource intensive, and all of the optimizations that we've built in source controller are not in the Kustomize controller. So
yeah, that's true. And those things adapt, right? So in terms, like it's a lot easier to kind of get those remote bases in, but as you scale and you start, having, loads of clusters that you're managing or loads of different applications, those things will add up. And as you said, like it will have a performance impact. You shouldn't need to kind of go out or you should avoid to need to go out to the internet every time you're doing reconciliation. Otherwise, you're adding things that might decrease your reconciliation ability, well, the ability to do fast reconciliation processes and get changes in as soon as possible. Yeah, I haven't seen any questions yet. Have you seen any questions there?
Oh. No. I see one person was able to find the Q&A panel at least, so it is correctly enabled. But we had a question very early about customizing Helm charts, and I answered that in the chat. I think Balas had to leave. But for the benefit of anyone who's watching the video, maybe don't have access to the chat, I'm not sure how this will work. There's a feature called Post Renderer for Helm that allows you to make any customization to your Helm charts without editing the Helm chart source. So maybe this is a Helm chart that is from some upstream that you don't control, and they haven't thought of an option that you needed. So you're able to add those things in at runtime for your preference. Things like maybe there's a pod that needs a persistent volume. It can be anything.
Yeah, that's definitely a quite cool thing. Um, I think we have a question now. So if nobody has questions, do you have a quick answer for what is the difference between Flux CD and Argo CD? Well, I'll probably not be able to help much on that because I don't know much about Argo. Do you know much about Argo, Kingdom?
I've used Argo a little bit. I'm not an expert in Argo by any means, but um, I would say the biggest, most notable differences from Flux perspective are around the resource footprint and security focus. Flux having a smaller resource footprint, Flux being able to run in an environment such as Raspberry Pi. Um, those are, and as far as the security footprint, that touches on the wonderful Argo UI, which I am a big fan of, but it is also a large attack surface, and it's um, significantly more complicated to secure than it would be for Flux, which has a fairly nil attack surface, where almost everything is a CRD. There are only a few ways into Flux um, as in the form of packets. You can contact source controller to fetch an artifact, and you can contact the notification controller to let us know that it's time to sync, but that's pretty much it as far as I'm aware. So security focus and resource footprint. There's probably more good answers that I haven't thought of. But
Yeah. One thing that I heard is that Argo CD is a monolith, but I haven't used that, so I can't tell for a fact. Yeah, and as Kingdom mentioned, Flux is quite modular. Like each controller is has a very well defined scope. There are owners of a specific scope. So source controller owns all your sources and stores the artifacts, which are then used by the controllers that apply changes, such as the Helm controller, which apply Helm releases, and the customized controller that actually applies customizations and so on. Cool. We have, well, I hope that answered the question, but again, like, I'm sorry, I don't know much more about Ergo CD Luna, so I can't help much more on that front. The other question is about, can we store Flux CD as a Helm package?
So I know that there is a Flux community Helm chart. It's not maintained by the official Flux team, but it is an option for folks who can only install things via Helm. That's been the main audience of people who use that, from what I could tell. The officially supported way to install Flux is through Bootstrap, and I think the next alternatively officially supported way is the Terraform provider. The Helm is sort of a distant option that I wouldn't necessarily recommend, but there are people who are using it successfully, yes.
Yeah, I know. I'll just kind of briefly talk on that as well. Like, a lot of folks use Flux to kind of bootstrap their whole cluster, so they just kind of use the bootstrap of the CLI to kind of make sure that they do that process, or then they use the Terraform, and that's it. Like, once that happens, the whole hydration of the cluster is managed by Flux. Flux will, make sure that all the state is reconciled and so on. So the only thing that folks would need to do is run either the bootstrap from the CLI or the Terraform, and then everything else like is just done automatically. So yeah, that is quite cool.
And I think that I have heard of one specific reason why you don't want to use the Helm chart necessarily, because the Helm controller can't upgrade itself, if I understood that correctly. So when you get to upgrading, it becomes problematic because the Helm controller starts an upgrade and then it gets interrupted itself before the upgrade's completed, and it would really like to track the upgrade from start to finish, and that doesn't happen. So it is complicated, and that's one of the reasons why we haven't published an official Helm chart. But if Your intention is to allow your users to manage their syncs through Helm. That's something that works very well. There's a separate chart for installing the Flux core and for installing. So the main drawback is that you can no longer use Flux to manage itself. That doesn't mean you can't upgrade. You can use Helm CLI to upgrade, but
yeah, and just on that point as well, one thing that is great about having the CLI is that you can do some checks. You can make sure that all the requirements, on the cluster are there, like you're running within. You're trying to install a version of Flux that is supported, that supports the version of the Kubernetes version that you have installed, and so on. So again, there's a lot of benefits of using those mechanisms, I would say.
yeah, and as far as upgrading Flux, my favorite way to upgrade Flux is by pull request, which is another thing that you would lose. If you go through the docs and find that under the Bootstrap upgrade in our install docs, there is a link to a feature called automatic upgrades, which is a GitHub action that will open a pull request for you, which you can merge to upgrade Flux. That's one of the very nice features of Flux managing Flux.
Yeah. So another question, this one from Klaus. Can I run Flux Bootstrap multiple times for the same repo, but for different clusters? Example, once for prod, once for kind.
Yes, you certainly can. Their Bootstrap directions will tell you to use a path such as clusters/my cluster, and the intention is that you could have more clusters that are in a sibling position of that directory. So you could bootstrap another one called clusters/kind, and then they can inherit from bases in the same repository and use the same manifests through Kustomize.
Yeah, that is, it's used quite a lot, right? Because then you can have everything in one repo and then just have different views or different cluster configurations using all the settings, all the YAML manifests you already have, just slightly changing here and there. I got problem. So Klaus just kind of follow up on that question, saying I got problems if I have different Flux CLI versions.
I think what we're probably addressing here is that you need to use the same version of the CLI with a particular version of Flux that's been installed because of API differences, usually, if the API has been upgraded. And that is something that we just got confirmation that was the issue. So if you are in the process of upgrading and if you're testing an upgrade, you will need to have multiple copies of the Flux CLI in order to do that. That is a little bit inconvenient, and I think that's something we intend to address after GA when the APIs will be a bit more stable.
Yeah, and that is probably like more problematic just for folks that haven't gone to source controller v22 yet, because we changed a few things on the API then. But yeah, from that point, once we kind of roll out that across all the APIs, that should be all right by GA, as you said. Brilliant. Any more questions? Anyone else want to share something exciting or any problem maybe you faced with Flux in the past and you trying to find a way around it? So I just wanted to share quickly a way for folks to reach out to us. Again, Kingdon is all over the discussions and like a lot of the community questions. He will be there, and like the Flux team is there as well. Maybe not as prolific as Kingdon, but if you guys have any questions, again, go to our org, or there's a discussions forum there. There's the CF Slack, which I'm not sure it's there, but you can find that on the Flux community page, which is the second link there. And just reach out to us, and we'll be more than keen to help get people up to up and running, or if they have any questions or doubts, we'll be more than keen to help.
And there's also, while we have KubeCon ongoing, there is the Flux booth, which is both in person and virtual. So if you are not at KubeCon and you're having FOMO, I've just put the link to the Flux booth, Flux information page. There's a link to the Flux booth on there. So you're welcome to join us anytime throughout the conference.
Brilliant. Well, thank you again, everybody, for joining in. And yeah, keen to see you guys on the community Slack discussions and issues on the GitHub. Brilliant. Cheers. Bye.